Welcome from my side too. As some may notice, I changed my title a bit, so empowering fast experimentation and reproducible machine learning. So you won't hear anything about how to optimize your models, but you will hear how you can improve your experimentation cycle so that it gets faster. There are two main topics, as I said. From my experience, when you're working in the field of data science, you always want to do a lot of experiments. You want to improve your model. You even terminate during the run and think, oh, I have to change some parameters so it will get better. And a lot from my former colleagues during university just didn't care so much about reproducibility. So I show you today how this can go hand in hand and show you how we do it at Codecentric. So why is reproducibility necessary for machine learning? There are a lot of things, in my opinion. Here are named three of them. At first, when you are working in a professional environment and you have a customer, if you want to deliver a model, it is always the question, how did you get the model? How did you train it? What architecture is it? What data set did you use? What hyperparameters did you get? So that you can tell them you need to store them somehow. The second thing is about how to get better models. You want to compare different experiments, the outcome of different models, and therefore you need to compare the performance of the model so you can choose what are the next steps to do. And the third thing is about finding the error of a model. For example, if you have a model in a production area running for half a year without any problems, and suddenly something went wrong. What is the solution of that to fix that error? And therefore you need all the information you can get about the training process. So here I'm going to talk about what is necessary to gain reproducibility. Essentially, it is to store everything which is happening during the training process. As I use Python in a machine learning environment, you need to store the software environment. That means which Python version you are using, but not only the version itself, but all packages which are installed in the environment. The second thing is the source code you are using. We use Git, therefore that's a solved problem. And also combination of the source code and the configuration file. Because when you run an experiment, you use specific source code and additionally usually some configuration files. And the last thing is the dataset plus the dataset version. Usually a dataset isn't consisting of a long period of time, but develops continuously, and we should store the information at the time we are training the model. And all the things should happen automatically. When you try to do it manually, it's firstly error-prone, and it's tedious work, and you will forget about some things you want to store. So all these things needs to be done automatically, so the user or the data scientist doesn't forget about it, or doesn't even need to care about it. It should be in the background. So the next, I will tell you, in my opinion, what is necessary to do fast experimentation. I have here 4 points on which I talk about in detail on the next slides. So the first is starting experiments, how that could be done in an easy way. The evaluation, to look how good the model performs. Then we need to compare the models. And the last case is to find some specific corner cases in our model, in our data set, on which the model doesn't perform good and how we can improve on this corner cases. So to start an experiment, you need to have access normally to some specific hardware. If this is a CLI access or a UI access, it doesn't matter, but you should have a good interface. I think 2 years back we had the idea as doing the training process as a GitHub CI/CD pipeline. That means you commit and push to a specific branch, then the training is run automatically, and afterwards you can investigate the results. We tried that out for a few months and noticed that isn't the right thing to do, because you always had to commit something and change it and commit, and that was a bit tedious way. And when you run an experiment, you didn't know what is currently doing, because the interface wasn't so good from GitLab that you could see what is currently happening, and so we choose a different way. So it's necessary to have a good interface to start a lot of experiments very fast and to see what is happening in the infrastructure. The second thing is the configuration. So in my opinion, it is good to separate the code from the configuration in a way that you can run the same code with different parameters. Let it be the learning rate or the number of epochs you want to train or anything else, so that you don't change the code for a different experiment with only slightly changes in parameters. And this I want to take further. So pipeline modularization. That means you have a usual training pipeline. For us, it is like training a model, predicting it on the data set, and then analyzing it. And you want to change only one thing from it, for example, the data set. I will show you how this is possible in an easy way later in some example. But you can take it as a way that all the components which can be exchanged are modularized in a pipeline. Evaluation starts for me as soon as you press the start button of an experiment, because usually you want to monitor the loss if it goes down, or any other metrics, so that you may interrupt the experiments if you did something wrong. So the monitoring is one crucial part of the evaluation. Of course, the metrics are also very important during the training or after the training on the test and validation data set. And in my opinion, it's also very good to have the model predicting the whole input data or test and validation data set to see how it performs on specific data points. We often have models which work on images, and there it is very good if you have images where you, for example, see which bounding boxes are predicted and which are missed. The comparison of the experiments is also a good point. As I mentioned earlier, the analytics is good if you look at one experiment, but you need to find a way where you have multiple or at least two experiments next to each other so that you can see the difference. And not only the experiment you did before, so the previous experiment, but even the experiment which you done half a year ago. So you can see immediately in an easy way, what did I change and what effect does it have on the outcome. So now about corner cases. What are corner cases? I think there are many, but for me it is where the model predicts something different as the ground truth says. So that could be the model says, for example, an error where no error is on an image, or there is an error on an image which is missed. So this divergence need to be something which needs to be easily found in the data set. And now I want to continue on our machine learning training workflow, and will explain how we managed to incorporate those things into it. So we have from the left to the right, we have at first the data, which is used to train a model. And during the training process, the model is optimized, and all the things we used there are stored in storage, so we can access it. It's not only the model, but also the other information which I mentioned earlier. Then the evaluation is done in an extra dashboard, which has access to the storage, and where we can investigate the performance of the models. We have a cycle, so if you do an evaluation, you start at the data again, either change the data or leave it, and at each step you can change something so you get better in the output of the model. And when the model performs well enough, you can deploy it at the customer and then start the monitoring. And the information about the monitoring is going back to the cycle again. So you have two points where you can get information. It's one from the monitoring and one from the evaluation, and there, which leads us back to the cycle. And this is how you continuously can improve the model. Today I will focus on the first part, and how our set of tools incorporate the capability of reproducibility, and also that you can really focus on fast experimentation. So about the data, I said that the data set continuously changes, and to really compare to experiments, you need to take into account if they are based on the same data or on the different data. So what we use to version binarized data is the tool called DVC, Data Version Control. It is a Git-like tool which doesn't store the data in Git, but only the hash information does it store on the Git server. So you have, like, for every version you have a commit hash, which is unique, of course, and you can get to any point back in time and restore the data. That means if you now are a half a year later, for example, and you want to retrain the model on the data for half a year ago, you only need to know the git commit hash. We store this hash with our experiment data, but you can also look in the commit hash history and then make a checkout at the point, and this means you have the identical data as for the training, which is very important if you, for example, have a customer error and you want to find out what the problem is. The training I focus a bit more on, because I have here a bit of an example, because I think it's good to explain how we do it here. So when you see here the training, it's separated into 3 steps here. At first, it's the optimization of the model, then the prediction on the data set, and then the analysis. And what we want to do, we want to take the same pipeline, the same training pipeline for all our customers. So we have like a training step, a prediction step, and analysis step, and each step cares for storing the information. The only thing which we as a data scientist need to do, we need to configure each step. I will do that here in an example of the data set, because different customers always have a different data set, but we build this pipeline in a way that all important things can be exchanged. For example, the model architecture or the optimizer, or how you analyze the data, how you store the data or how you store the prediction on the disk. And everything is done by an interface, and you only have to implement the interface. And you don't need to care about, okay, I want to have reproducibility. This is stored by the pipeline itself. You only need to focus on the parts you want to change in the experimentation. And we are using two tools here. One is called Dexter. It's an orchestrator. We build the pipeline with Dexter. And one is Hydra. Hydra is a configuration tool where you can modularize your configuration in different YAML files and import them into one big file. And it's very nice if you have multi-experiments and want to separate configurations from each other. I have now the example here of two different data sets. Let's say we have a customer A and a customer B, and we do the same at both customers. Here it is semantic segmentation. So we can use basically the same model architecture, the same optimizer, and everything else in the same way, but the data set is completely different. In one way, it's like gray images, on the other is RGB images. The labels are completely differently stored, and we want to have minimal effort to train both data sets, or both models for these data sets. And what we are doing here with Hydra, we are first implementing two different semantic segmentation data sets, one for customer A and one for customer B. I may have changed the name, but it's only an example. So these are completely different Python classes, which take care of loading and transforming the data in a way that it can pass to a model. And they are stored in two different YAML files. And what I do in the next thing is I have a main configuration file, which is used to start the training. And what Hydra allows, it has a special keyword defaults, and it's like import statements. So what I put here is a list of imports of other YAML files. For example, this line means look at the folder datasets and put the dataset which is loaded here, so the customer A dataset, at the dictionary ops train config dataset. This name is not chosen by me, but it is the Dexter default pattern. So in Dexter, each step is called op. We have the train op, so to speak, and we want to configure the train op, and the data set, that is how we named it, the data set should be loaded from here. So this file is going to go directly to this step. And the only thing which I need to do now to use the different data set is to specify here a different name, not customer A, but customer B. And in that way, there's a change in this data set. So If I now have things which are often reused, so for example, optimizers. I have different optimizer files, and they only need to be parameterized once and can be loaded from different machine learning experiments. That makes it very convenient way to have only a good overview of which configurations you have. If you start to copy all things in one big config and you move on to a different customer, if you try to start the old config a few weeks later, in my experience, it never worked. And in this way, you have a really consistent way of storing your configuration files and putting them to the pipeline. So the advantage of having a consistent pipeline, as I said, is it takes care of storing all information. And the advantage of using Hydra is that you have a really separated configuration files which can be even tested and loaded into the correct part of your training process. And that was about the training, and when the training is done, everything the pipeline stored is in just cloud or local storage. So you can choose if you want to have it in cloud, but most of our customers want their data locally on premise, so we are flexible to store it in both. One experiment has a unique ID, so we use the timestamp and alphanumeric 4-digit number. And what we store, as I said in the beginning, are the configuration files here. The commit hashes, we have one file, Git versions. There is the data set and the current hashtag of our code. And we have a lot more data. One is predictions, for example, where we store data frames if we are at classification, or we store their images if we are using semantic segmentation. And of course models, and I think the rest is important too, but I won't explain it into detail now. If we have now this information, is everything we need to do the evaluation. We thought about using MLflow in the beginning. What we came to the conclusion that it's unfortunately not flexible enough. For some use cases it's very good, but we want, if we work with images and we want to search for things where the model and the ground truth is too different, it's not possible as far as I know. And that's why we use Streamlit as an app, and we had built a dashboard for it. And here again, we have a default dashboard which loads the experiments, and you can display the basic information. And if you want to have specific components which, for example, this image view and search for some specific corner cases, you just implement one component and add it to your dashboard in a configuration file. And that is the main thing I want to show, because here is now again the overview. To wrap it up, to say you have a pipeline which takes care of the reproducibility, and you have a lot of tools which help you to do fast experimentation. And we try to use as many fitting tools as there are. The only thing which we have to implement it by ourselves are the interfaces of the machine learning pipeline. The other things are standard tools, but because we don't want to reinvent the wheel. For example, Dexter and Hydra are the main components for the training pipeline. We use Poetry as a Python version tool so that we can get the exact software environment which can be reinstalled at different systems. And for the evaluation we use Streamlit, but there are other dashboarding tools which are here, I think, similar. I don't think I need to say something about Git and cloud storage. That uses nearly everybody here, I think. And yes, the set of tools which I talked about, we want to do open source so that we can get more input for doing things better and feedback for it. And we started it yesterday to open source it as NiceML. So if you want to have a look at it and give us some feedback, it would be very nice. And thank you for your attention. And are there any questions?
Yeah, thank you very much. It's very nice to have the dida conference as an announcement platform for a new open source tool. I think I personally would be very interested to look into it. But now for our audience, yeah, what's about any questions?
Thank you for your nice talk. I was wondering, for the dataset versioning and the config versioning, what are the benefits over using, for example, weights and biases, which has most of this integrated and also provides like hyperparameter sweeps and stuff like this? What's your benefit over using weights and biases?
I haven't had a look at weights and biases, so I cannot compare it. We started with it, I think, 3 years ago. I don't know how old weights and biases is, but...
it's been there for a while.
Okay, so I have a look at it and then I can talk about it.
Okay, thank you. More questions? Yeah.
Yeah, thank you for the talk. Really nice open source lightweight stack, and I really like the custom Streamlit app to provide a good UX for observing, because I think that's often like when you look at MLflow or something, is like yeah, it's not a good experience. So my question is, so you're really showing more like the technical tracking and assuming that the objectives of the project has like one task or like the same business context. How do you put this into more project management, like higher level, like changing of the maybe business understanding or getting new requirements? How do you bring this into this workflow?
So from my experience, the basic pipeline stayed for years now the same, and what we want to store with it. We had now several use cases which we implemented, for example, semantic segmentation, object detection, classification, tabular data, and everything fitted in this pipeline. And for now, it's not, I haven't seen any.
I wasn't thinking about changes to the structure, but rather like within a project. If you learn something and you change the objectives, do you track this with like somehow like the context of like kind of learning inside the project that is not about like, for example, changing the objectives of what you're trying to do in a project?
Of course, I think that's not part of this, how we program it, but of course we have changes of what we do on which specific. So I don't know really what you're aiming at.
I'll ask later.
Okay, we can discuss it. I'm here the whole day, so.
Yeah, are there any more comments, any questions? Yeah, I see someone over there.
Yeah, it's a very interesting talk. I was wondering, when it comes to packaging Python packages, are you also trying like Docker, putting everything in a Docker file? And why didn't you use that solution? It's really interesting.
We are using that solution that incorporates with our tools. For example, we have this training pipeline on premise at our customers, and we use their Dexter as an orchestrator, and it runs like a Docker container for each experiment. Yes, but it's exactly the way we are doing it as a customer.
Thank you.
Thank you for your talk. So you mentioned you use Hydra's compose features extensively, right? So I suspect you have some sort of orchestrator that figures out what in the pipeline has changed and then only executes the stuff that has changed. Does that work out of the box with this compose feature? Because let's say the optimizer.yaml has changed, but in the main thing, right, the reference to optimizer.yaml obviously hasn't changed. That still changes the same, still is the same. So your thing that looks at the changes needs to be smart enough to know that the reference has changed, but the sort of template thing hasn't changed.
So what we do is we use, we run the pipeline completely, even though if you don't change anything, it will run from start to the end. We don't have like a way that, for example, if you say, okay, my training stays the same, but my prediction changes, then we don't only do prediction and analysis. That you need to do by manually. We have a pipeline that only does these things. This is our evaluation pipeline, and then you need to be aware of just using this. But Hydra would, so you need to change, of course, that you only use the configuration for these, but these are the same as for the training. So you just can kick out the configuration for the trained parameters and use them for those.
Okay, thank you.